I want to get back to the NVIDIA story from around the time and kind of this visionary nature of what NVIDIA has done and reflected in their share price is this idea that, okay, deep learning is going to be gigantic, or let's assume that deep learning is going to be gigantic. And so let's build a software ecosystem, going back to your point earlier, Sama,
Yep.
that supports that. So tell us about things like CUDA, TensorRT, maybe a bit of the history and why those are so important in this GPU ecosystem and in this AI era.
Yep. I'm actually going to start first with NVIDIA AI Enterprise, right? Just completing the story of how we're doing things, especially with Dell Pro-Max AI PCs. So think of NVIDIA AI Enterprise as our version of, end-to-end software development platform, which is helping you not just accelerate your data science pipelines, but also really helping you build next-gen. It can be generative AI applications, it could be computer vision applications, it can be speech AI applications. And it has a lot of components. We've got NIM Microservices. This is how we are delivering all kinds of AI models as containerized microservices. So literally think of any AI model in the world. We work with open source partners, proprietary partners. We have our own NVIDIA AI models as well. We're taking each of these AI models, putting them into a container, and then adding our I won't say secret sauce because everybody knows about TensorRT LLM and all kinds of services which are really helping you get the best inference possible on NVIDIA GPUs. And we're offering them as microservices. And the reason being, and you'll start seeing this from NVIDIA perspective, that we are providing almost all of our AI software as microservices, is because things are changing quickly. I'm a developer today who built an application with Llama 3. And guess what? In 2 months, Llama 3.1 comes. And then another 2 months, 3.2 comes up. So we want to make it really, really easy for people to just swap in the model as quickly as possible without really disrupting that entire pipeline. So that's NIM Microservices. We've gotten all kinds of models from if you want to build a digital human to actually building speech-related applications to now we also have NIM Microservices for our reasoning AI models as well. So that's the first component of NVIDIA AI Enterprise.
Really quickly before, so it's going to be obvious for sure to you, to both of you, as well as to many of our listeners, exactly what a microservice is. But could you define that for our listeners that don't know, just so that they understand what it is and why it's important, why it's helpful?
I actually don't have a definition of microservice.
Well, I'm going to give you not like a textbook definition, but I'm going to give you a practical definition, right?
Cool.
Is let's say you're, a data scientist and you have created, let's just pretend, a chatbot with Llama 3. And you create that without a microservice, without, an NVIDIA NIM. Like Sama said, every time that model updates, if there's security, all this stuff, you're doing a ton of, I hate to say it, but background tedious work to get that to a point where you can deploy it, where when things change, for example, if you don't, that's the whole point of a microservice with NIM, is you basically can load that to literally one line of code, and the LLM part of it is really done for you. It is containerized, it's packaged, it's ready to go. So a data scientist can focus on, well, how am I going to customize it or building whatever application wrapper around it, versus like, ooh, I need to update the code here to get this to connect. Like, that's really the point of a NIM, is how quickly can I leverage the power of an LM vision model, whatever, with one line of code. That's the power of a NIM. And it runs on a workstation too. It runs on Dell Pro Max servers. It runs pretty much everywhere.
Yeah, that was going to be my point, that the key point being with these NIM microservices, you don't have to make sure that the AI model is tuned to the GPU, right? We've done all of that work for you. So as soon as you're downloading this locally on your Dell Pro Max PC, it already understands the kind of GPU it's running on. The only thing you have to make sure is the model you're downloading fits onto your GPU memory size. Now, but with 96 gigs of memory, you've got the entire world for you here.
Nice. And so I've been trying to, as you've been speaking, I've tried to kind of look up quickly online what NIM stands for. It doesn't seem to stand for anything that I can find easily. It just sounds, okay.
I'm going to let the secrets out. It actually stands for NVIDIA Inference Microservice. But then we also use NIM microservice. So it's like chai tea kind of a thing. They mean the same thing.
Right. Potato. Yep.
Nice. A potato.
Potato.
A potato brand potato.
Exactly. Cheese queso. That's what I would say. I go ahead to a restaurant, I'll say, I want cheese queso. And then my wife always gives me a hard time. But yeah, cheese queso.
Nice. Yeah. Now I understand perfectly. Thank you for giving us that insight. It's interesting. It isn't something that's very public. So people really are getting the inside scoop on NIM. And yeah, it's just spelled NIM for our listeners who are wondering what word we're saying. It's exactly like it sounds.
Yep.
NIM in all caps. And I'll have a link to that in the show notes, of course. Anyway, so I interrupted you. Oh, go ahead. Someone.
Oh, I was just on the same topic of NIM Microservices. I was going to say we've got a website called build.nvidia.com. That's where we host all of these NIM microservices. It's a good website to not just go try out these different kinds of AI models. You have the ability to prototype on the website itself. There are no charges for it at all. You can see models, again, by all kinds of partners that you work with, including NVIDIA models as well. They're segregated by the industry you work with or the use case you're trying to build. So it's easy to kind of maneuver around, find the exact model you want to work with. And then once you want to download this, we've made it easier. So if you really sign up for our NVIDIA developer program, we actually let you download these models and then continue to do your testing, experimentation free of cost. There are no charges at all. So you can continue as a developer. I would want to go try out different kinds of models, see what's working with my application. So we let you do that as well.
Fantastic. That was a great rundown. What I was going to say, and I'm glad that you had more to say on NIM Microservices, because my transition was going to be that the last time I interrupted you, you were about to, I think, start talking about other aspects of the AI enterprise. So now I'll let you go on that.
So outside of NIM Microservices, we've got NEMO, which really helps you build, train, fine-tune your own models, but also gets you the ability to add guardrails to your model so that, whenever you're deploying your application, you are making sure that the application gets used exactly the way that you want to do it itself. We've got AI blueprints. Think of these as reference AI workflows. So we give you the ability to build different kinds of AI applications. So think of this as a recipe. You've got the step-by-step process to actually build an application. There's a reference architecture. But we also get you the ability to add your own data to it. And that's what gets every company their own edge, right? You want to add your data, which is your differentiation at this point in time. So you have the ability to build different kinds of applications. What else do we have? Oh, we've got different kinds of frameworks and tools. So we actually do support different kinds of AI frameworks like PyTorch, TensorFlow. We also have our CUDA library. So I think this is a good time to kind of talk about CUDA as well, which really stands for Compute Unified Device Architecture.
I didn't know that. I've been using that word for like a decade now. Thank you.
So this really has been playing a crucial role in AI development by enabling efficient parallel computing on NVIDIA GPUs, right? So the idea was that this entire architecture really helps you train different kinds of models significantly faster, which means that you can, in some scenarios, actually reduce your training times from weeks to days, right? It is also helping you get better and better inference. So you see higher inference performance on NVIDIA GPUs because of this architecture of parallel processing, if you're comparing it to just CPU-only platforms. We now have, and I'll have to look up the right number of how many CUDA libraries we have, but we've got tons and tons of these CUDA libraries, and these are GPU accelerated libraries. So a good example I'll give you is of Rapids CUDF, right? So the idea, and Logan touched on this earlier as well, is the way Rapids CUDF works is that it tends to mimic the APIs of a lot of data frames like pandas, polars. So if you are in that process of pre-processing your data in your data science workflow, it can actually accelerate that entire process by 100x on our 6,000 GPUs. Without any kind of code change. That's the beauty of it, that as a data scientist, all I'm doing is adding that one API line of code, and then it actually accelerates the entire process by 100x. So that's like massive time saving from a data scientist perspective. At GTC, we announced QML, which is, again, one of our CUDA libraries as well. This is helping you accelerate your machine learning tasks as well. So if you're using skitlearn, you have the ability to go up to 50x acceleration for your ML tasks as well. So each one of these libraries, and as I said, we've got tons of these right now, but depending on the data science task that you're doing, these are all designed to then offload that work to the GPU so that you can see that massive acceleration.